Hey guys, I just wanted to run through some solving equations from our workbook. So you watched a video on Wednesday on how to solve polynomial equations through factoring. And all the ones that we did were kind of set up nicely for you to do. And when I say nicely, I mean all of the terms of the polynomial were on one side and it was set equal to 0 on the right side. Those I would consider easy because all you have to do then is factor and set each factor equal to 0. Again, remember the little kind of game that we played where we said if I'm thinking of two things that multiply to 0, one of them has to be 0. We tried it in class when we said if I have two things that multiply together to give me 1, we found that no, neither of them had to be 1. That property in math only applies when it's set equal to 0. All right, so in the problems that you did on the video for homework on Wednesday were already set up to be nice and easy in the sense that everything was on one side and it was set equal to 0. But what I want to look at today is when they don't quite match that, all right? So a couple things that I want to remind you that and you don't have to write them on this paper, but you should write them somewhere else. The highest exponent equals the number of solutions you should find. All right, so here the highest exponent is 2. We should get 2 solutions. Here it's 3. We should get 3. Here it's 4. We should get 4. So don't forget that as you go through. There are opportunities, plenty of opportunities for you to forget that and give the wrong number of solutions. Usually you give too few. It's not that you would ever give too many. The second thing I want to point out, and this is specifically relating to why these polynomials are considered hard, is that there are usually about 4 things that could go wrong that would make them fall into the harder category. The first thing is there might be parentheses. All right, now parentheses aren't always a bad thing. If we have 2 parentheses or 3 parentheses and it's set equal to 0, that's a good thing. All right, that means you're already ready to go. You have it factored and it's set equal to 0. But a lot of times what we'll see in these harder problems is that we end up with parentheses and it's equal to something that's not 0. So maybe it's equal to a number or maybe it's equal to another polynomial. If that's the case, then this falls into the harder category, and I'm going to give that a sad face because what we have to do is get rid of the parentheses, all right? So this is going to be one thing that we need to do. I'm going to put in this space because I'm not going to do, actually I'll put it in this space. I'm not going to do this one with you. So one is get rid of parentheses if the polynomial is not of this form. And when I say this form, I mean this one. So parentheses, parentheses equals 0. All right, the second bad thing or thing that might make these harder is that sometimes your polynomial is split. And so we have some terms on the left and some terms on the right. So make sure all terms are on one side. All right. Once you do that, that falls back into the easier category because then all you have to do is factor. All right. The third thing that could make this harder is that your leading coefficient is negative. So we want to make sure that the leading coefficient is positive. All right. Again, all our factoring that we've done has kind of relied on the fact that that leading coefficient, let's say this, is positive. That's how all our factoring works, that we're assuming that that's positive. So we would have negatives elsewhere, but that one's always been positive. So if for some reason it's not, maybe you transpose things to kind of the wrong side and you ended up making that negative, make sure you change it so that it's positive. All right, and that would happen by either multiplying everything through by a -1 or dividing through by a -1. And the fourth thing that could happen that would make this fall into the harder category is if your terms are out of order. Again, we like to have it so our exponents go from highest to lowest. Sometimes they'll be rearranged, and again, that makes it more difficult to factor. So put your terms in order. Right? If you've done those four things, then you've put it back into a situation where we would call it an easy polynomial to solve, an easy polynomial equation to solve. All right, so let's just do one quick one together right here of the easy kind. Again, I'm saying this is easy because there are no parentheses. All the terms are on one side so that it's set equal to 0 on the other. The leading coefficient is positive, and all our terms are in order. I only have a y squared, so really there's no other term to put in, in a different order. At least it's not 1 is out front, -1 is out front, and the 16y squared is at the back. So I would say that this is in a good order. So again, what we did in the video yesterday was he said, okay, I remember the trick that we talked about in class, and you saw in the video, and we would say, okay, what I need to do is get this factored so that I have a product of two things equaling 0. So I would look at this polynomial and I would say, how do I factor it? First thing I do is I check to see if there's a GCF. All right, hopefully you're shaking your head, no, there's no GCF. Then I would move down to the next factoring technique, which is difference of squares. And that's what it is. All right, so we're going to factor this polynomial right here using difference of squares. So I'm going to set up two parentheses, and I'm going to say this is 4y and plus 1 and minus 1. All right, so now I have it in that form that I want. I have a product of two things equaling 0, therefore one of them must be 0. All right, so either 4y plus 1 equals 0 or 4y minus 1 equals 0. All right, so now I have two equations, linear equations that I have to solve. So for this one, I'm going to move the 1 over to the other side. It becomes 4y equals -1. And I'm going to divide by 4, so it's -1/4. And for this one, I'm going to move the 1 over. It becomes +1. And divide by 4, and I get y equals 1/4. So these are the two solutions that make this equation true. And let's just check one of them. Let's check the -1/4. So to check it, what I do is I plug it back into the original equation. So is 16 times -1/4 squared minus 1 equal to 0? So I'm going to do the exponent first. So -1/4 times -1/4 gives me +1/16. So 16 times 1/16 minus 1, is that equal to 0? Well, 16 times 1/16, these just cancel and I get 1 minus this other 1. Is that equal to 0? Yes, it is. And you could check for that one also. Okay, so then let's take a look at some new ones. I still would classify this as easy, but I just want you to see, again, as I said, the highest exponent tells you how many solutions you should get. So this would be our first one where we would have more than 2 solutions, I think, if I'm remembering correctly. So we should get 4 solutions at the end. I just want to make sure that you get all of them. So otherwise, though, it's set up as we would hope. We have our polynomial on the left, we have 0 on the right. All right, so then we would look at this and say, how can I factor that? So first thing we would try is GCF. All right, hopefully you saw that there is an x squared that they have in common. So when I factor that x squared out, I get x squared minus 1 left over. All right, now we said if we get a binomial and it has an exponent that's higher than 1, then what we have to do is check to see if that factors again. Right, and so in this case we would say yes, actually this is an easy a difference of squares. So I'm going to leave this x squared out here. Do not drop that. All right, if you do, you will not be able to get all 4 solutions. All right, so then this is x plus 1, this is x minus 1 equals 0. All right, so now I have a product of things here equaling 0. One of them has to be 0. But you know what I'm going to do first, because I want you to be able to see where this fourth 0 comes from. I'm going to write x squared as x times x, and then times x plus 1, x minus 1. So I have 4 things multiplied together to give me 0. That means one of them has to be 0. So either x equals 0, or x equals 0, or x plus 1 equals 0, or x minus 1 equals 0. All right, well, this kind of seems dumb because they say the same thing, but again, what we need to remember is that we have to get 4 solutions. What this is saying is that 2 of them are identical, all right? And that's fine, but we just have to account for all 4. So there's 1 and 2. Now we have to worry about these. So x plus 1 equals 0. That's just a quick transpose right there. That says x equals negative 1. And this one right here says x equals positive 1. So our 4 solutions are 0, 0, negative 1, and positive 1. There's all 4 solutions that were guaranteed in this problem by that exponent right there. Now, again, sometimes people say that's so dumb. Why do you have to do that? Again, we have to account for all 4, but there's a shorter way to write that. Sometimes people will write these solutions, x equals negative 1, x equals positive 1, and then what they say here is x equals 0, and they say it's a double root. All right, again, you might not understand where the word root comes from. It means the same thing as solution. All right, so it's a double solution, but we call it a root in math. All right, so that is also another way that you can write it, because again, somebody that sees you only giving 3 that knows that they should be expecting 4, they're going to say, wait a minute, you shortchanged me there. I'm expecting 4 and you only gave me 3. When you write that right there, double root, they say, oh, okay, I see. You gave me all 4, but this one gets counted twice because there were 2 times that it came up as 0. Okay, hopefully you're doing all right. Let's move on to problem 4. So in problem 4, we again have this nice situation where all of the terms are on the left, and then we've got the 0 on the right. I'm including this one because, again, we've got higher than 2 here, and I want you to see what happens. So, again, now that this is equal to 0, we're just going to go through and we're going to say, okay, how do I factor that? So think about that for a second. Hopefully you're just going through that list that we keep, going through. Every time we do one of these in class, I ask you the same thing. So first thing is there a GCF? And we would say, yep, there is. There's a factor of x. All right, so we've got 25x squared minus 10x minus 3 equal to 0. Again, I'm just reminding you, we're expecting 3 solutions, so don't drop that because that's going to provide one of our solutions. All right, this has higher than, it's more than a linear. It has an exponent higher than 1, which means that we need to factor it again, or at least attempt to factor it again. All right, so what factoring technique are you going to use? Hopefully you said harder general trinomial. All right, so I have a product. I'm looking for a number. I'm looking for 2 numbers that multiply to 75 that subtract to 10. All right, 2 things that multiply to 75 that subtract to 10. Let me just come up with a list here. So 1 and 75, no to 2, yes to 3, that's 3 and 25, no to 4, yes to 5, it's 5 and 15, and there it is. Those 2 subtract to 10, but they multiply to 75. All right, so I'm going to change this to grouping. So this is going to become 25x squared. Now, 1 is going to have to be positive and 1's negative because the sign here is negative, so they must be different. And I need that when I add them together to get a negative 10, that means the larger one has to be negative. So I'm going to choose the negative 15x. Again, as we discussed in class, don't forget to write that x there. Minus 5x, nope, sorry, plus 5x, I was just kidding there, equals 0. Now I'm going to do grouping. I'm going to put these parentheses right in here, or a bracket right in here, because I'm going to have parentheses inside of it when I do the grouping factoring. So this ends up being grouped together, and this grouped together. Here I've got a common factor of 5x, so I get 5x squared minus 3. Nope, just 5 minus 3. And then this is 5x minus 3 equals 0. Again, I just did those brackets because I have parentheses inside of it, so it distinguishes which is which. Okay, now I'm going to go through and I'm going to say, oops, my goodness, I'm just going too fast. Again, if there's nothing in common, I put that 1 out front. All right, so now when I take out the common factor, it's 5x minus 3, and then I'm left with a 5x plus 1 equals 0. Notice I keep writing this equals 0, equals 0, equals 0, equals 0. Don't ditch that. You need to keep that in there because you've got to remember that you're not just factoring, you're solving, and that's what it's equal to. Okay, so now I have a product of 3 things equaling 0. I have this, the 5x minus 3, and the 5x plus 1. So one of them must be 0, right? So either x equals 0, or 5x minus 3 equals 0, or 5x plus 1 equals 0. Right? Well, this one's already solved for, so I don't need to do anything there. That is one of our solutions. Here I'm going to bring the 3 over to get 5x equals 3, and then I'll divide by 5 to get x equals 3/5. Here I'm going to bring the 1 over, and I'm going to get 5x equals negative 1, and then x equals negative 1/5. All right? I was expecting 3 solutions. I got 3 solutions. Again, if you had factored that x out and just dropped it, you would have only ended up with 2 solutions, and you would have to go back and figure out why you were missing a solution, and it would come from you having dropped that. So don't drop it, pull it out front, and it's going to serve as one of our solutions. Okay, let's take a look at number 5. This, I would say, is not in our nice easy form because again it fails many of these things right here. So we're going to look, and first it says get rid of any parentheses. Well, there aren't any, so we get to skip that one. That part is fine. Second, make sure all terms are on one side. They are not all on one side. All right, we've got some on the left, some on the right, so that's one thing we're going to need to take care of. The second is make sure the leading coefficient is positive. All right, here is my leading term. All right, because it's got the highest exponent and it is not positive. All right, so we're going to have to make sure that we take care of that. Third is put your terms in order. Clearly, they're not in order here. They're spread apart anyway on different sides. So we've got a lot of work to do. We need to make sure that we take care of all 3 of those things. I'm going to take care of all of them at once. And the way I'm going to do that is because I notice that my leading coefficient is not positive right here. When I move all my terms to one side, I'm going to choose to move these terms to this side rather than these to this side, right? When I move this negative x squared to the left side, it's going to be a positive x squared, and then my leading coefficient will be positive, right? Again, if you don't pay attention to that and you forget, it's fine. It just means that you'll need to do a second step. I'm going to try and do all of these at once. So I'm going to choose to move these because I have to move either this to this side or this to this side. I'm going to choose to move this over here so that while I'm doing that, while I'm getting everything on one side, I'm also making my leading coefficient positive. And when I do it, I'll be sure that I put everything in order. And again, when we say in order, we mean that the exponents go from least to greatest and the constant term is last. Okay, so let's do that. In moving these 3, I need to subtract a 3x from both sides. I need to add an x squared to both sides. I'm going to put it out front right here so that when I combine things, they're all in order. And I need to subtract a 5 from both sides. Hopefully you wrote a little bit smaller over here so your work isn't quite as squishy. All right, x squared has nothing up here to combine with, so this is just going to be an x squared. X minus 3x gives us negative 2x, and 2 minus 5 gives us a negative 3, and that's equal to 0. And what I've just done in that one step of moving things over from the right to the left is I've changed it from what we would consider a hard, because it's not in our nice easy form, and I've made it an easy problem. All right, so now we just have to look at this and say, okay, now I need to factor that. All right, so how would you factor that? Hopefully you would say it's an easy general trinomial. So you're going to factor it into 2 parentheses. And again, that you would recognize that we're looking for 2 things that multiply to 3 that subtract to 2. And the larger of those 2 numbers has to be the one that's negative, because again, this says that the signs must be different. All right, so I'm going to put an x here and an x here. The 2 things that multiply to 3 that subtract to 2 are 3 and 1. So we've got a 3 and a 1, and the larger, the 3, must be the negative, and this is positive. Now, again, I've been saying things like x minus 3 equals 0 or x plus 1 equals 0 because I have a product of 2 things equaling 0. If you're ready to skip this step and go right down here and say if x minus 3 is 0, then x must be 3. And if x plus 1 equals 0, then x must be negative 1. If you're ready to skip this step, feel free to go right here. I would, at this point, still encourage you, when the leading coefficient of one of these factors is not 1, that you should still continue to write that out, because you're going to need to solve. Again, eventually you'll get to the point where you don't even need to do that, where you can just jump from here to here. But at this point, I'd say if the leading coefficient is not 1, please still write it out until you get a little bit more confident. A lot of times you'll give the wrong answer, like 5/3 instead of 3/5, or -5 instead of -1/5. So for now, let's just keep doing that. But if you're ready to make that switch to just skip this step right here and put it right, just x equals 3 and x equals -1, I'm fine with that. If you're not ready, keep writing that out. That's fine. Okay. So I would say, just because this one is a non-traditional one or a harder one, I'd say let's check it just to make sure that you see how you would do that. So let's check the x equals 3. So what we're going to do is go back to the original equation, and we're going to put a 3 in everywhere we see an x. So here, instead of x plus 2, we're going to write 3 plus 2. And we want to know, is that equal to 3 times 3 minus 3 squared plus 5? Remember, when you're checking, you cannot cross over on the other side. So don't try and move the 3 and the 2 over onto the right side, because we're trying to prove it's equal. And if we move things over, then we're assuming it is equal. So we can't assume that. That's what we're trying to prove. So just keep simplifying on one side until you get it as simplified as possible. And then we want to show that we end up with the same thing on each side. So on the left, we end up with 3 plus 2 equals 5. On the right, this side's a little bit more complicated, so we need to do order of operations. So we have a multiplication, a subtraction, an exponent, and an addition. So order of operations says do the exponent first. So we're going to have 3 times 3 minus 3 squared is 9 plus 5. Now we have a multiplication, subtraction, and addition. Order of operations says do the multiplication. So we get 5, I'm going to keep carrying that down on this side, equals 9 minus 9 plus 5. 9 minus 9. Again, we have subtraction and addition. Order of operations says do whichever comes first when you go left to right, addition or subtraction. All right? So because the subtraction comes first, that's the one we do. It's not always do addition first. You do whichever one comes first when you're just down to subtraction and addition. So it's 5 equals 0 plus 5. And then, yes, that says 5 equals 5. So that one definitely works, and you should check the other one when you have a chance. All right, the last one I want to do with you is problem 7. All right, in problem 7, again, we're looking at this and we say, oh, that's so not an easy problem. We have so many things wrong here. First of all, we have parentheses, and it's not set equal to 0. Second thing is we've got terms on both sides. We don't want that. So we've got a lot of work to do. And again, I just want to remind you, if you're in the form parentheses times parentheses equals 0, don't multiply them out. You're already set and ready to just set each factor equal to 0. But if it's any other form, All right, something times something equals a number or a polynomial, or maybe you've got something times something plus something else here outside plus a number equals a polynomial. If it's any other form besides this one, you must get rid of the parentheses. All right, let's do that first. All right, so think about how you would approach that. All right, I'm going to choose to multiply these two together first. I could distribute this x into here if I wanted to, but I tend to choose to multiply the two binomials together first and then, kind of get the harder thing out of the way first and then distribute that. Just remember, this x can be used only one time, so you may either multiply it into this, x plus 6, or you may multiply it into the x minus 4, but you can't do both. All right, so I'm going to do these first so that that also eliminates that question. Once I multiply these two together, then I'll just distribute that. All right, so I get x squared minus 4x plus 6x minus 24 times this x outside equals 24x. Okay, and then let's distribute that x. So now it's x cubed minus 4x squared plus 6x squared minus 24x equals 24x. Now, you know what I did that I could have done? I could have just added those two together first before I distributed. I'm not sure why I didn't do that, but I'll just do it right now. All right, so I'm going to get x cubed minus, plus 2x squared minus 24x equals 24x. All right, so I got rid of the parentheses. That was the first thing. Second thing on our list, make sure all the terms are on one side. And down here, we can see that that is not the case. We have a positive 24x on this side. We need to get it moved over. Now, don't be tricked into thinking that these cancel out. When this moves over, it's going to become a negative 24x, which will add to this other negative 24x. They won't cancel. So I've got x cubed plus 2x squared. This is going to be minus 48x equals 0. All right. Now I'm ready to factor. All right. Everything's on one side. My leading coefficient is positive. My terms are in order. All right. So how would I factor that? All right. Hopefully you said you would take out a GCF of x. All right, when you do that, you get x squared plus 2x minus 48 equals 0. Again, don't drop this. Now that we've multiplied this out, we can see that we're expecting 3 solutions. So if you drop that, you're going to lose one of your solutions and only be able to give me 2. All right, so then we have to try and factor that. That is an easy general trinomial, so I'm looking for 2 things that multiply to 48 that subtract to 2. And the larger of them has to be positive. All right, so let's think about things that multiply to 48. That would be 1 and 48, 2 and 24, 3 and 16, 4 and 12. None of these are subtracting to 2. I'm thinking about that as I go on. 5 doesn't go into it. 6 does go into it 8 times. There we go. 6 times 8 gives us 48. All right, so I'm going to have x, and then x and x here. I've got to put an 8 in and a 6 in. One of them has to be positive and one has to be negative. And again, this tells us the larger one has to be positive and this one has to be negative. And again, note that I keep writing that equals 0 the whole way down. All right, so now I have a product of 3 things equaling 0. Therefore, one of them must be 0. All right, so I'm going to set each of them equal to 0. X equals 0. X plus 8 equals 0. X minus 6 equals 0. And that's going to give us x equals 0. X equals negative 8, and x equals 6. All right, and again, you could check that, but remember to check it back in the original equation. The reason for saying to check it there as opposed to, say, right here is because if you've made a mistake in multiplying things out to get from here to here, then all you're doing is verifying that it's a solution to this, not to this. So always go back to the original to make sure it works in the original, right? I think that's the last one I planned on doing with you. So I have assigned some more of these for you to try on your own. Okay, good luck. Let me know if you have any questions.